Hello and welcome to another episode of our welding spacecast. Alright guys, so here we go. We're going to talk about chapter 10. It's called Striking an Arc. Guys, if we don't understand how to strike an arc right now, we're up, against some big bad stuff right now. Okay, so we need to make sure that you guys do know how to strike an arc. But I'm pretty sure you do. Okay, so onwards. Let's see what we got. Alright, so this is not a very long PowerPoint, but I need you guys to understand. What makes a good weld? What makes a bad weld? How do we do this? What this thing should talk about is how do we make a good weld? So let's really sit down and talk about this, and I want you guys to be able to really think about this as I speak with you, okay? So the first thing is that we're going to talk about travel speed. Travel speed is how fast you go along the joint. So how do we know we're too fast or how do we know we're too slow? Well, when we go too quickly, the bead becomes rather thin, kind of ropey looking, okay? Or if I'm still going too fast, or I might be even too hot, it looks like there's little arrows in my bead rather than little ripples. It looks like little arrows in my ripples, okay? And that tells me I'm going too fast. Now, when we think about it, there's a logical part that, of our brain that says, hey, this is really, really hot, guys. Move a little faster. So then that takes us down to amperage. How hot is it? How do I know when it's too hot? How do I know when it's too cold? Well, let's think. Let's also determine if I'm going too slow. My travel speed is too slow. My bead is going to look kind of like a little caterpillar. It's going to be really built up and tall. Okay. And then amperage. How do I know what's too hot and how do I know what's too cold? Well, if it's too hot, it's going to be really, really flat. And it's probably going to be pretty wide too. Okay. And if it's too cold, it's going to kind of sit on top. The toes aren't really going to, I could say, blend in with your base metal. So we need it to blend in. And, there's other things that affect it. So that's really important to have. So we know that travel speed is essential, right? It's important that we have that variable. And we have to have the correct amperage, okay? Too hot or too cold, we're going to have problems, right? If my amperage is too high, my brain is going to tell you, hey, look, this is really, really hot. We need to move faster. So now having an incorrect amperage is also going to affect my travel speed. I'm going to have an incorrect travel speed. So as you can see, it's this big snowball that's coming down the hill at you if we don't have everything that's correct, okay? The other one is arc length. What is the correct arc length? What should I have? Well, arc length should be the diameter of the rod that I'm using. So if I'm using an 1/8 inch diameter rod, that means the interior portion, the metal part, not the flux, is 1/8 inch. That is the core wire. Okay, so if it is an 1/8 inch, my arc length should be no more than 1/8 of an inch. Okay, now what happens if my arc length is too long? What's going to happen? Well, because we have that arc length changes. When we're using a constant current machine, that machine is always trying to keep that constant, let's say 100 amps. Okay, and if my arc length becomes too long, the machine is going to go into autocorrect mode and go, hey, look, buddy, I'm trying to keep this 100 amps, so I'm going to give you more volts here, which means it's going to make it hotter if I go too far away. Well, now this changes my amperage. This changes everything, right? So we need to remember that as well. And the other one is angle. Guys, angle is not easy. We need to remember how everything works. So I talked about flat position first. Flat position is 1, right? Whether it's a fillet or a groove, 1F or 1G, we know that it is 90 degrees straight down. That is our what? travel angle. Our work angle means we're going to be able to tilt it 15 to 20 degrees so we can see where we're driving. Okay, now what about horizontal? Horizontal, we should have a 45 degree. So you guys need to pay special attention, especially in horizontal position, that you get the correct angle. Because ultimately, when we create a bead, half of the bead should be on the top and half of the bead should be on the bottom. Okay? So if we're having a hard time, we need to really assess our situation. And if you look down the edge of your plate and notice that you're not even, then you know that your angle may be off. That also comes down to another thing. It comes down to body mechanics. Now, this really isn't what makes a good weld, but I'll tell you, this affects what makes a good weld. If we have incorrect body mechanics, it makes it hard for us to get the correct angle. Our body fatigues, and I want you guys to think about your future. If you have habits now that are incorrect, in the future, those habits will follow you. So if you're have an incorrect angle or incorrect body position, and you go and try to do this for 8 hours or 10 hours, your body's going to be really fatigued. Okay? So we need to think about this. So whenever we weld, we want to make sure that we are dead on, straight in front of the joint that we are welding. If you are off to the side just a little bit, your weld will be off to the side just a little bit. So it's really important to pay attention. And then not only that, we also need to make sure that it's not too low or too high. Yes, of course, welding in the field, you're going to have to do something really, really low, or you're going to have to do something really, really high. But until you get the right idea, you guys need to work on how it is. So in order to get the most out of your most bang for your buck, you need to look at the little dent in your neck to the end of your ribs. That area is the area that you want to have your plate in all other positions but overhead and flat. Okay? So for horizontal and vertical, you need your plate in that area to make sure that you continue to have the correct angle. Okay? And angle, let me tell you guys, I struggled with it. Okay? But now let's talk about it. Well, what makes a bad weld? Well, if I have incorrect travel speed, more than likely I'm going to cut into my base metal and I'm not going to be able to fill it up because I'm moving too quickly. If I'm moving too quickly, I can create what's called undercut. Another name for these are sharp bites. Okay, they look like little sharp bites. What happens is if we move too quickly, we're not giving time for the metal to fill up. Okay? Or what happens if my arc length is too long? Well, I'm making it too hot. I can burn into something and cut it and not be able to put the metal back. Same thing, undercut. Amperage, too hot, I can make undercut. Angle, incorrect angle. If I'm not moving straight into my joint and having a manipulation right where I was, I can create undercut with my angle as well. So we can see that anything that makes a good weld can also make a poor weld if we don't try to do all of the things correctly. Okay, it's a big snowball, let me tell you. All right, of course, we need equipment. Dun, da, da, da. If we haven't figured this out, we're kind of not doing well. All right, anyway, so we also need a stick machine. What type of machine are we going to need? Okay, not just a stick machine, one that is capable of constant current. Okay, we also need to make sure that we have electrode lead, that's the cable, electrode holder. What do we need to know about the holder? It needs to have jaws that are going to clamp, that they're clean so we have a good connection to the electrode, right? We need to make sure that it is correctly insulated. Same thing with our lead, we need to make sure that there are no cuts or burns. The other thing with our lead is, and they call it a splice, whenever they hook another one together. We do not want a splice more than 10 feet to what we're working on, okay? So we want to make sure that we have a minimum of 10 foot from the connection, okay? Of course, we have the workpiece connection or the lead, or I should say the ground, okay? And the ground lead. We want to make sure that we have a proper ground. If the ground isn't, correct, we can have an issue with connection and we might not get a good weld. All right, of course, guys, clamp the bare end of the electrode into the holder. What happens if you don't put it in the bare end? Ideas or thoughts? Well, if we don't put it into the bare end, what's going to happen is that it just can't strike. There's not enough connection through the flux to strike. All right, here we go. Make sure you inspect your equipment. You want to inspect your equipment every time you weld, okay? Make sure the machine is on the correct polarity. DC electrode positive means my stinger should be hooked up to the positive. DC electrode negative, my stinger should be on the negative. We also want to make sure that we don't put the electrode holder on a metal surface when it's on because it will weld it to the table, okay? We also want to make sure that we turn the machine off and remove the electrode from the electrode holder when we're done. We also want to make sure that we start with a current range. How do we determine current range, okay? So the best way to determine current range, and I kind of talked to you guys, is put it into a decimal, okay? So if I have a 3/32 rod, putting that into a decimal, so 3 divided by 32 is around 0.090, thereabouts, okay? If I pull that point off, it would give me 90 amps. So it gives me an idea to start at. Okay, how about an 1/8 inch? 1 divided by 8, okay? You guys can do this on the calculator if necessary, okay? And it comes out to 0.125. If we knock off that point, it's 125 amps. Now, it gives me a good idea where to go. Kind of puts me dead center of what that rod can do, but we need to make adjustments, okay? We're going to get a scrap metal, and this is why I tell you guys, get a scrap metal, adjust your stuff. You need to make sure that it's doing what you want it to do, okay? So yeah, somebody's going to hand you a rod and says, here, weld it. You're going to have an idea of where to start from. Now, let me preface this by, hey, don't weld on something you don't know. Don't use a rod that you don't know. I could be handing you a stick of dynamite and you're going to light it up and blow yourself up. Make sure there's a stamp on it. Make sure you know what it is, okay? And then make your adjustments from there. Let me tell you, I've had more guys get jobs from the way they adjust their machines. Ask, you're going to a job, ask for a piece of scrap. Hey man, let me get a piece of scrap so I can set this machine up the way I want it. Okay? It will help you immensely. As always, take care, guys.